Hello, everybody, and welcome. My name is Alicea, and I'm a senior developer advocate for games at Unity Technologies. And today I'm excited to share how you can streamline your game development workflows using Unity visual scripting. This feature empowers game creators of all backgrounds to create logic and interactions for their games using node-based graphs instead of traditional C# scripts. This feature is really useful for non-programmers and programmers alike, and it includes an API for advanced tasks, custom nodes, and more. But before we jump into the details, let's take a look at how it actually works. Now, back in 2020, Unity acquired the visual scripting feature known as Bolt, and has since changed the name and integrated it into the editor as a native feature, which is what I'll be showing you today. In this example, we have this Terraformer character, and we're going to add a behavior to her with 3 visual scripting units. One to detect when the player presses a specific input button, a second to trigger one of her animations, and a third to change the color on one of her materials. Now with just those 3 units, we've created this behavior, and in a couple of minutes we'll jump into the editor so I can show you some more complex examples of things that you can do with visual scripting. Now, when using visual scripting, there are a couple of things to keep in mind as to how it can help your development workflows, whether you're a solo developer or you're working in a team with many talented people. The first is that this feature is particularly useful for rapid implementation or prototyping of interactive systems, art, animation, you name it. Let's say you're a game developer and you want to test some values or a new mechanic for a health system that you're working on. Or you're an animator and you want to see how some animations get changed when the player enters a dialogue scenario. You can use visual scripting to test and implement these behaviors yourself without having to learn a bunch of potentially complex C# code, or without having to ask your programmer and then spend time waiting for them to implement that for you. Unity visual scripting will let you work independently and seamlessly with the rest of your team. And I say seamlessly because you can also use visual scripting with traditional C# scripts. Now, if you are a programmer on your team, you can have visual scripting graphs be attached to your C# scripts so that your game designers or artists can modify or extend your work that you've created in your scripts. Or you can use C# to create custom nodes or other development tools that your team can take advantage of when working with Unity visual scripting. Now, speaking of C#, it's also a very useful tool for people who want to learn how to work with C#. Unity visual scripting is similar and follows some similar concepts, and it's a much easier way to get your feet wet with learning scripting than it is for jumping into traditional C#. So it's similar enough that as you're using visual scripting and you get more skilled with it, you'll find that you'll be able to understand C# code a lot better and eventually jump into using it. And the only thing that you'll have to learn left is the syntax of it all. Now, Unity visual scripting is also very useful for creating templates and tools for other Unity users, not just the folks on your team. We already have wonderful community members who are creating different extensions or tools that you can use with visual scripting, and even game templates. For example, a 2D platformer template that's created with visual scripting that the whole community can use. So we definitely encourage folks who are interested in making templates and resources for the community to use visual scripting for that. And lastly, we just want to mention that you can use Unity visual scripting in production for Unity versions 2018 and above. This tool has existed for many years. It's definitely been battle tested. And so you can use it for any of those versions. And let me kind of know on the specifics of that. If you're using Unity visual scripting in version 2021.1 and above, visual scripting is integrated into the editor. So there's no additional assets that you need to add. Everything's ready to go. Just add a script or state machine component to your game objects to get started. Now, if you're working with Unity 2018, 2019, or 2020, then you'll want to integrate Unity visual scripting via the Unity Asset Store. So right now it's currently listed as Bolt. So you can go to Bolt on the Asset Store, download that, import it into your project. And then once you do, it'll automatically open up the Bolt Setup Wizard And that's how you set up all your different types and assemblies and settings that you want to have for your visual scripting environment. So it's much more fun to show you all of this than just talk about it. So I'm going to jump into the editor now and show you how to navigate the Unity visual scripting UI. I'm going to show you how to work with script machines and state machines and things to keep in mind as you're working in your graphs. And then I'm going to show you how to use visual scripting to create some game mechanics and also how to use it to work with C#. So let's go ahead and get started. Let's start with this 2D endless runner platformer game. It's mostly set up already, but essentially we're going to have this player character here run across this field and jump over obstacles as they approach her. Using Unity visual scripting, we're going to add the specific behavior she needs, and we'll also create some logic to handle what happens when the game is over. So let's begin by adding a visual scripting graph to our character, Penny Pixel. I'm going to select her in the inspector, then select Add Component in the hierarchy and search for Machine to find the two visual scripting components, one for a script machine and another for a state machine. Most of the time when you're using visual scripting, you're going to use a script machine. It works like a linear series of events. The nodes you add to it execute in the specific order you created them in. In comparison, a state machine is a collection of different nodes and behaviors that run whenever certain conditions are met. So you could have a state machine that handles player states like when a power-up is active or when they receive damage, and the state machine will automatically transition between these states as needed. We'll jump into state machines a little bit later. For now, we're going to add a script machine component to our game object. In the script machine, we have two options, source and graph. For the source, we have an embed source and a graph source. In most cases, you'll likely use the graph source, which saves your visual script as an asset within your project files. Since it's saved as an asset, it can easily be reused by any other objects in your scene or project. Alternatively, an embed source will quite literally embed your visual script into the component itself instead of an asset file. This means it can't be easily reused, but instead gives you the ability to make direct scene references, and I'll show you how that works in a bit. Let's set our source to graph and press New to create a new graph asset. I'm going to call it Player Behavior. Now that we have our graph and the component, we can give it a title and description to keep our project organized. Once that's done, we'll click on Edit Graph to open up the Script Graph window. Each graph asset you create comes with two default nodes, which are formally known in Unity visual scripting as units. These include a start unit and an update unit, similar to what you'd see when creating a new C# script. For this example, we won't need these units, so I can click and drag to select and delete them from the graph. Now I want to show you the main sections to be aware of within the Script Graph window. The first is the Graph Inspector, which you can open with the G icon in the top left of the window. This is an important tab to have open, especially if you're new to visual scripting, because this is what gives you contextual information about your graph and any units you may be working with. Right now, it's showing information about the currently active graph, but if I add an example unit here, say set velocity, now when I have it selected, the Graph Inspector can tell me what this unit does, any applicable options this unit has, what data it requires for its inputs, and what type of data it outputs. So if you're trying to figure out if a unit can work for you with what you're trying to achieve, add it to your graph and check it with the Graph Inspector. You can learn a lot about it that way. The next section to be aware of is the Blackboard tab, which contains all the variables you'll be working with in your project, very similar to the Blackboard windows in Unity features like Shader Graph and Visual Effect Graph. There are several types of Unity visual scripting variables, the first being graph variables, which are only applicable and accessible to the specific graph that you're working on. Then there's object variables, which apply to the specific game object you have selected and can be accessed by any script or state machine on that game object. You may have noticed a variables component appear in the inspector when we created our script machine component. These appear automatically whenever you add a machine component to an object, and they are what hold the variables specific to our object, so you can add or modify them via the inspector or in the Blackboard. They're both the same thing. Scene variables can be referenced by any object within the same scene, App variables can be accessed across multiple scenes. And lastly, save variables can be accessed throughout your project and persist even when the player quits the game. In this case, for our player character, the behavior that I want to create for her is to jump whenever she approaches an obstacle. So I want to give her a jump strength variable so we can control that jump height. I'm going to select the Object Variables tab and add a new variable called Jump Strength. Click the plus sign to add it, set its type to be a float, and we'll give it a value of 8. Now we're going to add the first couple of nodes to create this jumping behavior for our character. To create a visual scripting unit, right-click on the grid background to open the Fuzzy Finder. This is a contextual menu that lets you peruse all the units you can use in your graph, or search for them by typing in the search bar. I want the player to jump when the jump button in our input system is held down, so I'll go to Events, Input, On Input System Event button. On the unit, we can select the input we want to use and set its action to be On Hold. All script machine graphs require a green event unit like this one in order to trigger the chain of events we'll create with our nodes. Since our input actions are saved on our Game Manager object instead of the player character, we have it saved within a scene variable that we'll drag into our graph so it can be referenced by that input unit. The next thing we'll do here is set the character's velocity on its rigid body. So we'll create a vector2 and add some units that update its values and applies it to the character. Right-click to add a unit, and we'll type Create Vector2. I'll select the option that shows both X and Y so I can customize both values. She's not going to move left or right on the screen, only jump, so I'll grab her current X value with a Get Velocity 2D unit. A helpful tip to keep in mind if you're not sure how to use an output from a unit, instead of right-clicking to add a unit via the Fuzzy Finder, you can drag an output of a unit and release it to see suggestions on which units will be most applicable to use. When we do this with the Vector2 output of the Get Velocity 2D unit, we immediately see suggestions for Vector 2D units, which is what we're working with, and this includes a GetX unit we need for our character. We'll connect the X value into our Vector2, and for the Y value, we'll just add the jump strength variable we created earlier, dragging it into the graph via the Objects Variables component or the blackboard, like we did with the Input Actions variable earlier. We'll then connect it to our Y value input. Notice how the nodes we have are all grayed out. This is because we have the dim setting turned on, which darkens nodes that aren't being activated or triggered in the graph. They're dimmed because we haven't connected them to our input unit, which kicks off the flow of logic throughout the rest of our graph. Once I connect the input event unit to the Vector2 node, we can see they all light up as they're activated by our graph's flow and become part of our chain of events. The next part we want to add is to actually update the player's velocity with the Vector2 that we've created. To do this, we can add a set velocity unit and take the output value of our Vector2 and connect that to the new unit. Lastly, let's activate her jump animation by adding an animator set bool unit. There's already an animator attached to this game object that uses a boolean called jumping, so we'll add that to this unit and set the boolean's value to true. Now that we're ready to test our visual script, let's go ahead and jump into play mode. We now have our character running across the field, and when we press the input button, we can see her jump into the air and her jumping animation begins to play. Her jump animation isn't getting reset because we haven't added that logic yet, but I wanted to enter play mode to show you one of the most powerful features of Unity visual scripting. Notice how when I press our input button, you can actually see the flow of events pass through the units in real time. This gives you a way to visually understand how your units are working together, and it's especially useful to use for debugging when a script isn't working as intended or you're getting an error, as you can actually see how each step of your visual script is being executed. Let's get out of play mode so we can add the rest of the behaviors for this character. We'll reset her jumping animation when we release our jump input button. We don't even have to enter all the needed units manually again. We can just select the relevant ones we've used previously and use Ctrl-C to copy and Ctrl-V to paste them in. We can then connect them and set the animator's Boolean value to be false, so she'll stop doing her jumping animation. For our next step, we're going to add a collision check system to our graph to detect when the player collides with an obstacle. When you're working with visual scripting, you'll often come across systems like this that you'll want to use over and over again or across multiple objects. So instead of having to manually enter the same units for this behavior every time we need them, we're going to create a super unit for this behavior instead. Super units are essentially nested graphs that you can use repeatedly throughout your project to save you a lot of time. To create one, we'll go into our Assets folder, right-click, and go to Create, Visual Scripting, Script Graph. I'm going to call this SU for Super Unit, Collider Check, and click Edit Graph in the inspector to open it. Since we're using this graph as a super unit, it's important that we give it inputs and outputs so it can be used like other units. We can do this via the Graph Inspector window. To add ports for our graph's logic flow, we need to add a trigger input, which we'll call enter, and a trigger output, which we'll call exit. We'll hide the labels for both so we only see the green arrow indicators on the unit. Next, we need to define what kind of data we'll input into this super unit. So what are we checking for? We're looking to see if the player character collides with an object that has a certain tag. Therefore, the first thing we'll add to our data inputs is a key called collider with its type set to collider 2D. We'll then add a second data input called tag and set its type to string. Now that our inputs and outputs are set, we can use the fuzzy finder to add units for them to our graph. If we search for input, you'll see different types of input units to choose from, so be sure to use the one listed as input in nesting. Our next step here is to add an output unit. Now we can see all the inputs and outputs we've created within our graph and use them to route the data from our collision check behavior. To create the actual collision check, let's add a compare tag unit. This unit will compare a tag on a collider with the provided string. So we'll connect our collider and string inputs to this unit and then add an if statement unit to verify the result of this comparison with a Boolean. If the tags match, we'll direct the flow of our graph into the output unit so we can continue with our sequence of events. That's all the steps we need to create our super unit. This is just a small example for the sake of time, but know that super units can really come in handy for nesting larger portions of your graph in order to help with performance, organization, and graph readability. Going back to our player character, we'll add an onTriggerEnter 2D event unit and our new super unit, which we can access in the Fuzzy Finder's Graphs folder or by searching for it. So when the player collides with an object, that incoming object's collider will get passed into our super unit via the onTriggerEnter unit. We'll extend out the string input on our super unit to get a string literal unit, which we can use to enter the tag we want to use for our comparison. The tag we want to check for is obstacle, which is the tag on the obstacle game object that the player has to jump over. Let's now add an animator set trigger unit to trigger her hurt animation. Then lastly, we're going to destroy her with the destroy unit. I'm so sorry, Penny. We'll give it a delay of 0.7 seconds and use a this unit to tell it to destroy the game object this graph is attached to. Let's go back into play mode to test this out. You can see when we collide with the obstacle, the player does her hurt animation and is destroyed, but our game is still running. We haven't created any logic yet to trigger a game over sequence. So to do this, we're going to create a state machine. Going over to our Game Manager game object, I'm going to add a state machine component, and this time I'll set its source as an embed so we can make use of scene references. Let's call it Gameplay States and click Edit Graph to open it up. Our new graph is set up with a default state machine using a single start state. We don't need a start state though for this example because we're only going to create a state for when our game is over. Because of this, I'm going to right-click on it and click Toggle Start so the state doesn't begin automatically when we start our game. I'll also use the Graph Inspector to change the name of it to Game Over State. We'll double-click on it to open it, and we can see that it contains what's essentially its own script graph. This is where you can add the different behaviors you want to happen when this state is active. It includes 3 units by default. 1 to trigger units when you enter the state, 1 to trigger units during every frame the state is active, and a third to trigger units when you exit the state. We don't need the last 2 here, so we'll delete those, and now we'll add the following units. We're going to destroy the obstacle she collides with the destroy unit, and drag in the obstacle object from our hierarchy into its target field. This is the power of using an embed, making these direct references to other objects in the scene without having to save or handle those objects as variables. Next step here is that we want to change the text used to show the player's score to say game over instead. We can do this with a Text Mesh Pro UGUI unit. Something important to remember is that if you want to use Unity visual scripting with packages or tools that aren't native to the editor, you'll need to add the assemblies and types for those features via the node, library, and type options available in the visual scripting menu within your project settings. To have their corresponding units available for use in your graphs, you'll also need to click the Regenerate Units button. I've already added the Text Mesh Pro assemblies and the Text Mesh Pro UGUI type to my project, so let's go back and add our Text Mesh Pro UGUI set text unit. We'll grab the game object for our text from the canvas in our hierarchy and drag that into the unit, then set its new string to say game over. Lastly, we'll use a set active unit to display the restart game caption we currently have hidden in our scene. Now let's go back to the main view of our state machine so we can create the transition that will actually activate our game over state. Since we aren't creating additional states for the sake of time, we can right-click and add an any state unit that will allow our transition to activate no matter what state is currently active. To create the transition that will start our game over state, we can right-click on any state and select Make Transition. An arrow appears on the cursor and we can drag it over to the game over state to create the transition, which appears as a small bubble on the connection we just created. Double-clicking the transition opens it up, and we can see there's a trigger transition unit inside of it. We'll need this to trigger our game over state whenever the player collides with an obstacle, so we can copy-paste the same units we used on Penny Pixel and connect them here to the transition unit. We're now ready to do our final play mode test. And we can see when the player eventually collides with an obstacle, we can see the behaviors we created for the game over state happen in our game. Before we go, I want to quickly show you how you can use Unity visual scripting alongside C#. I have a second project here that contains a spaceship shooter prototype created with visual scripting, but also makes use of C# in 3 distinct ways. For context, I want you to picture a team of programmers, artists, and designers working on this game. One of the programmers has made a complex projectile shooting system based in C# with object pooling and so on. But meanwhile, one of the designers currently just needs a visual scripting unit that will fire a projectile when triggered. Since the programmer already has a method in one of their C# scripts that can fire a projectile, the designer can make use of it as a unit by adding that script to the game object they're working with and dragging its C# script component into their graph. From there, they can use the fuzzy finder to choose the method they want to use. In this case, the one called shoot projectile. The designer then combined it with some units to apply a rate of fire, and the spaceship can now shoot its lasers whenever prompted in the script graph. We have a second unit in this graph that uses a C# method in the same way, but this one includes parameters for the method, and they appear as editable options when we include it in our visual scripting graph. Programmers are also able to access data from visual scripting to include within C# scripts, helping them to work more seamlessly with their teammates. This script we used earlier also shows how you can access visual scripting variables and custom events within C#. In 2 of our methods here, we're setting up a reference to access one of our visual scripting scene variables, and another to trigger a visual scripting custom event. Lastly, Programmers can create custom extensions and units for their team using C# as well. We're currently in the process of updating our documentation to bring clarity to this workflow, but I wanted to show you a quick example of how it works. In this case, one of the designers asked for a unit that could play a random audio clip from a list, and our programmer was able to create it by using the following script. It includes the namespace for Unity visual scripting, attributes to define the unit's category and subtitle description, and a class that inherits from the unit type instead of mono behavior. It then defines the unit's variables, inputs, outputs, definition, and the pick random audio clip logic we want it to achieve. Once you're done creating a custom unit script, be sure to regenerate your units via the Visual Scripting project settings so your graphs can access this new node. You can then use the fuzzy finder to add it to your visual scripts. So there you have it. Script machines, super units, state machines, and visual scripting plus C# combined. You're now set with all the basics behind Unity visual scripting and have the context you need to start trying it out on your own projects. So before we wrap up, I want to leave you with some resources that you can use to advance your visual scripting skills. If you just want to learn more about the feature in general, check out the features information page on the Unity website. We also have our documentation for the tool that you can check in case you have any questions about the specifics on how it works. And I invite you to come hang out with us and talk about all things Unity visual scripting on the brand new forums for the feature on our Unity forums. So it's a great place to go ask your questions, see what the community's talking about, and even show off your own visual scripting projects, which we'd love to see. And lastly, we also have a GitHub repo filled with different projects and examples that you can download and look through and reference as you're working with visual scripting. And it includes all of the projects and demos that I showcase in this session today. So with that, I just want to say thank you so much for tuning in. Again, my name is Alicea, and I'm always happy to help with any visual scripting or Unity questions that you may have. So feel free to reach out. And I hope you enjoy the rest of your GDC Showcase. Take care, everybody. Bye.